Okay, so in this video we're going to look at annuities in financial maths. So annuities are something where you have regular payments or repayments. So that could be something like an investment account, a pension account, savings certificate, or else maybe something like a car loan, house loan, mortgage, anything where you have regular payments. And there'll be compound interest applied, and it'll be over, weeks, months, years, and so on. So this type that we'll look at in this video are investments. So we see here 4 payments of €100 are paid into an account at the beginning of each year for 4 years at an AER of 5%. So we see here it's yearly payments and the interest is charged yearly, so that's all okay. We have our formula, F is equal to P times 1 plus I to the power of T. Now if we have a look at our first payment, we'll call it F1. So for each of them, P is 100, the interest rate is 0.05 and T is equal to 4. So if we have a look then for this first payment, so €100 is invested, T will be 1, 2, 3 and 4. So 100 is invested, 1.05. That first payment that's lodged is going to sit in the account for 4 years. Then our second payment is 100 times 1.05. and it gathers interest for 3 years. The third payment will earn interest for 2 years, and the last payment will earn interest for a year. So we have F2, F3 and F4. So we see here we have a series developing. If we were to change the order, 100 times 1.05 plus, so in reverse order, 100 times 1.05 squared plus 100 times 1.05 cubed plus 100 times 1.05 to the power of 4. Now if there were any more than 4, if it was 10 payments or greater, we'd use our sum to n formula for a geometric series. But because we only have 4 payments, it's okay to work these out manually. So we have 100 times 1.05 plus 100 times 1.05 squared plus 100 times 1.05 cubed and plus 100 times 1.05 to the power of 4. So that'll give you 452.563125. And then your answer at the end, just to 2 decimals, 4.52.56. So there's what it's grown to. Okay, so if we look at our next example, then what we have is €600 invested at the beginning of each month for 5 years. AER is earned at 5.4% paid and compounded monthly. Find the value of the investment after 5 years. So the first thing we need to fix before we start the actual question, we have an annual interest rate, but it's compounded monthly. So that means for us then it'll be 1.054 is going to equal 1 plus or to the power of 12. So we get the 12th root of 1.054 equals 1 plus or. And then we subtract. So this will give us quite a small decimal. So the 12th root, 1.054. Yeah, you'll get 4.39, so on by 10 to the power minus 3. So you can just add in your 2 zeros. And for or we get 0.004392322. Okay, so now we can go for our formula. So for our investment, it's €600 at the start of each month. The interest rate, keep it as its long decimal. And for T, this is just where we have to be careful. It's 5 years, but it's invested every month. So then we're going to have 5 by 12, which will give you 60 months. Okay, so now we set up our series. We have f is equal to 600 times 1.00439232 to the power of 1. So that'll be your final investment. So I'm essentially skipping the step like here where I wrote it year by, or investment by investment, because in this new question that wouldn't be effective in terms of time because we have 60 investments. So I could see here that it starts off to the power of 1, power 2, 3, 4, and so on. So we take the same approach here. We're just cutting down on a step, that's all. Squared. So I've established my pattern there, and I know that my last one would be 1.00439232 to the power 60. Okay, so I've established my series there, and now I'm looking at my sum to end formula. So that's in your log tables, and it'll be always this formula that you use. So A, our initial term, is 600 times 1.00439232. It changes by the interest rate every time. And N we know is 60 because there's 60 investments. So our sum to 60 is 600 times 1.00439232. And we'll put in a square bracket here, 1 minus or 92322 to the power of n, which is 60, all over 1 minus or. So you get 1 minus 1.00439232. So just be careful putting this into your calculator. Set up your fraction form. 600 bracket 1.00439232. Close that bracket. Open a bracket again. 1 minus another bracket 1.00439232. Close that bracket to the power 60. Come over again and close your initial bracket, and then all over 1 minus 1.00439232. Okay, so we get sum to 60 is equal to 41,267.28944. Okay, so no clarification on rounding, so I'll go for 2 decimal places, and we get 41,267.29. Okay, so now if we look at the second question, we'll see it's the same set of figures. €600, end of each month, 5 years, annual equivalent rate 5.4%, compounded monthly, find the value of the investment. So what's changed is, if we see here, it was invested at the beginning of each month, but now it's being invested at the end of each month. So what we'll do is our interest rate, we'll skip ahead a little bit. We don't need to repeat our steps, so we know it's 0.004392322. Okay, then we have 600 being invested. There's our interest rate. We can write, I instead. And then just what we need to be careful about here is for time. Because it's invested at the end of the month, we're going to be 1 short on the compounding period. So earlier on our series, we ran from 1 up to 60. So we'll still have 60 months. But instead, it's going to run from 0 all the way up to 59. Because if you think about it, when we're investing the money, if I go to my last month in year 5, on the last day, I go to lodge my money, but then the whole investment has matured and it comes back out to me. So my final lodgement doesn't earn any money. So that would be to the power of 0. So we set up our series then. So same series, just our powers will be 1 less. So we get f is equal to 600 times 0.00439 2322 to the power of 0. Then we'd have to the power of 1. So if you have any question, an investment question that mentions end of the month, it'll be the same idea there. To the power of 1, and so on. And then the last payment. So this is, well, technically the first investment into the account. And that sits in it for 59 months because it's the end of the month. So again, sum to n formula. So it's a times 1 minus or to the power of n all over 1 minus or. Now I know all of this just tidies up to 600 because anything to the power of 0 is 1. 600 by 1 will give you 600. So a is equal to 600. Just to make it a little bit neater to sub into my formula, or 0.00. Sorry, this will have been 1 plus or. So my interest rate is 1.004392322, and then T, there's still 60 investments, just to remember that, because 0 all the way up to 59 will still give you your 60. So our sum to 60 is going to be 600 times, we'll do our square bracket anyway, 1 minus your interest rate to the power of 60 all over 1 minus or. So just if we look back up to compare the questions, here the starting term was 600 times your interest to the power of 1. Inside the square bracket will look the same and the denominator is the same, but just our a value is different now. So sum to 60, a little bit easier to put into the calculator. So you can go back to your previous sum if you want and just delete your interest rate from the 600, or else you can enter it as a new value, same difference. So we get 41,086.82288, and we just need to round to 2 decimals. So 41,086.82. There's our answer. So just to compare the two answers, I suppose, if we invest at the start of the month, we'd come away with 41,267, compared to end of the month, 41 and 86. So it's not a huge difference, about 40 euro roughly, but just always be careful if it's start of the month or end of the month for an investment account, savings account, pension account, anything like that. Okay, so that's us done.